Hey, Tim DeStasio here. It is Psychrometric Saturday. This may be one of the most important ones that I've done because we're going to talk about how biological growth can form on the inside of a wall cavity, which happens in a lot of houses. And biological growth, which includes mold, forms as a result of condensation forming. And we know that condensation happens when humid air hits something cold and that water vapor falls out of the air in the form of condensation. That's what we want to avoid. But it can happen inside a wall cavity. I'm going to show you how using psychrometrics. So on the outside of the wall cavity here, we have a typical wall assembly. It's 85-degree dry bulb, 70 degrees dew points. Plotted that with the red dot. Now we've got a typical wall. We've got brick. And then on the inside of the brick, we've got a vapor barrier like a house wrap. Then we've got some sheathing, a 2x4 wall cavity with R13 inside of it, and finally dry wall right here. On the inside of that wall is 65-degree dry bulb, 55-degree dew point. That's represented by the green dot here. So we can see there's a pretty big difference in moisture between the inside and the outside, and that's what we want. Unfortunately, we have no control over how this house was built, so we don't know whether this vapor barrier is even in place or how well it was put in. So the dew point inside that wall cavity could be anywhere in between these two numbers. And if it's a really high dew point inside that wall cavity, somewhere close to 70 degrees, then if that wall cavity gets anywhere below that temperature, condensation is going to start forming. So let's say that we've got a customer that has bullied us into oversizing a system and he wants it 65-degree dry bulb in the middle of summertime. If the inside of this wall cavity gets anywhere close to that, then we're going to start forming condensation because we're below the dew point of this wall. That's a problem. So what's the lesson here? We cannot allow customers to dictate what our design temperature is. Our Manual J indoor summer design temperature should be 75 degrees because that is well above the dew point that could potentially be inside that wall. Here's another lesson. If we're delivering air via either a floor register or a ceiling register and we're blowing that cold air against that wall, again, we could be turning the inside of this wall cavity to a temperature that's below the dew point of the air inside that wall, causing condensation. Here's another lesson. If we're delivering air into a really small room, like a closet, like a powder room, like a water closet, and we're delivering too much of that air because we didn't do a proper test and balance, then the whole temperature of that room when the door closes could get really, really low. We could drop below the dew point inside the wall cavity and again start forming the biological growth that we do not want to have. So there are a lot of lessons here involved with building science, but understanding dew point, understanding the importance of having a good vapor barrier on the outside of most houses and most climates is a really critical thing to avoid really bad stuff growing inside the walls. Thanks for watching. I know we've covered a lot today. Thank you for your patience and tune in next time for Psychrometric Saturday.